today we're going to look more at solving logarithms. We have practiced how to rewrite a logarithm in exponential form and rewrite an exponential in logarithmic form. But we know how to solve logarithms, or we know how to convert logarithms to exponential form, and we're pretty good with exponentials. So that's where we're going to start here. And curly Q method allows us to convert the logarithm to an exponential. So we start with this 9 here. That's our base. We're going to curly Q around to the x, and then we're going to finish at 81. So when we rewrite this logarithm, which, by the way, a logarithm is simply another way of writing an exponent, it turns into 9 to what power equals 81. And if you've been doing the quick recalls, you should be able to immediately say, well, x equals 2. 9 times 9 is 81. The key is, can you rewrite the logarithm as an exponential? This says log base 8 of x equals 3. So when we rewrite this, we're going to start with the 8, and we're going to curly Q around, finishing at the x. So this is going to be 8 to the 3 equals x. If you've done the quick recall, you know that 8 cubed is 512. And if you need to, we can flip over to the calculator. So we pull up that and we say 8 to the 3rd power, and there's the 512. Again, a logarithm is another way of writing an exponent, so don't get caught up in this word log, log. But when we take a look at our next problem here, we're going to curly Q. So it's x, and then we're going to curly Q around, and we're going to finish with the 16. This becomes x to the 4th equals 16. And then we need to figure out, well, what does x equal? Again, if you've been doing the quick recall, you know what x equals. If you haven't been doing the quick recall, it's a little bit more tricky. But what we have to do is we have to undo to the 4th power. And to undo to the 4th power means that we are going to take the 4th root of both sides. Raising something to the 4th power and taking the 4th root, those are inverse operations, and that's going to give us back our x here. But we probably need to figure out how to use our calculator on this next one. And as I flip over to the calculator, the buttons that we use are going to be, we're doing the 4th root, so we're going to do 4, and then math, and then number 5. So it's the x root on function number 5. So I'm going to put 5, so the 4th root, and then 16, and that's going to give us 2. Talk to your math teacher, especially if you have an older calculator or a different calculator, to get help on how to do that. But once again, we're still using the curly Q method to solve this logarithmic equation. So we start with our 5, and we're going to curly Q around. When we curly Q around, we're converting this logarithm to an exponential, and this becomes 5 to the 2nd equals 3x plus 1. And use your calculator if you need to for 5 squared. I hope you don't need to. 5 squared is 5 times 5, which is 25, which equals 3x plus 1. And then we're going to solve by subtracting 1 for both sides. So we get 24 equals 3x. And divide both sides by 3. We get x equals 8. So just solving the way your Algebra 1 teacher taught you to solve. The thing about logarithms is we don't have to have equal to something in them. We can still use the curly Q method here. But as we look over here in the box, think about what we said above. What you're doing here is a logarithm is another way of writing an exponent. So we're finding the exponent when something's written in this kind of format here. So if we want to figure out what the log base 3 of 27 is, we're asking ourselves 3 to what power equals 27? And the exponent then on that is going to be 3. We can still use the curly Q method on these types of problems. So if we take a look at this, start with the 7, our base, curly Q around, then it becomes 7. I'm going to use x for our exponent. 7 to what power equals 1? Well, 7 to the 0 equals 1. Same idea on 6. B, sorry. Curly Q around. This becomes 6 to what power equals 36? Well, 6 times 6 equals 36, so that means that we have 2 for our exponent. Curly Q, start with the 2. So this is going to be 2 to what power equals 8? Well, 2 times 2 is 4, times 2 is 8. That means our exponent is 3. And that's what we're doing. A logarithm is another way of writing an exponent. So what these blanks equal is the exponent. 5, curly Q around. 5 to what power equals 625? And that's going to be 4. When we look at letters E and F and G, same idea here. Curly Q around. 4 to what power equals 1/4? So 4 to what power equals 1/4 if we need to write something down. And what happens is we started with 4, a whole number, and we ended up with a fraction. How did we get that 4 that technically was up in top of the fraction down to the bottom? Well, what we did is we used a negative exponent, because negative exponents flip and change the sign on the exponent. So our exponent on this particular problem is -1. And it's the same idea on letter F. We take 6, curly Q around, 6 to what power equals 136. But once again, we had a 6 that was in top of the fraction, and now it's in the bottom, or at least part of it is. How did we get from 6 to 36? Well, 6 times 6 is 36, so that gives us an exponent of 2. But because the 36 is in the denominator, this would be -2. And that's when you want to check maybe you want to check with your calculator, did I get that right? Finally, here, on letter G, the thing that we need to remember from our previous notes is, what is the missing base on this problem? because we are missing that. Well, when we don't have a base written, it's understood to be 10. And then we're going to curly Q around. So this becomes 10 to what power equals 1? And what we know then is 10 to the 0 power equals 1. Two types of logarithms. The first logarithm is what we've been working with so far, and it is called a common logarithm. The abbreviation for logarithm is what we've been seeing, the log, and we just talked about it on our last problem. When we see log, it's understood to be a base 10, and that's actually what your calculator uses. On your calculator, you have base 10. So if we flip over here and look at log of 78, the log button is to the left of the screen and 4 from the bottom. Here's log and 78, and we can look at our value here when we press enter. We also have to do, just to save a little bit of time for me, we also have to fill in what does log of 10 equal. Well, I don't really need a calculator for log of 10, but if we type it in anyway, we get 1. So our log of 78 is 1.892. So 1.892. And what we got with our special case of log of 10 is 1. Just a real quick explanation of this bottom special case. Remember, this would be 10 to what power, or 10 to what power equals 10, because it's understood that this base is 10. Well, 10 to the first is 10. There's another logarithm, and it is called a natural logarithm. The abbreviation is ln. If you're in French, where that came from is, in the United States, we say natural logarithm, but in French, they say logarithm naturel. So it just flips it around for any of you taking French. The base of a natural log is e. Remember, not a variable, it's a number. And the button that we use on our calculator is third from the bottom on the left. Third from the bottom. Here's the natural log. And we are typing in the natural log of 126. And we get that decimal. The other one, the special case, is the natural log of e. Reminder that e is second in the division symbol. And then we can look at that as well, just to save a little bit of time while we're on the calculator. So there are two numbers, 4.836 when we round it appropriately. 4.836. And the natural log of e is 1. Once again, a reminder, for the natural log, what happens is when the base is not written, and it most of the time is not written, for the natural log, it's e. So then when we convert this, it's e to the x equals e, and e to the first power equals e. So as we get close to finishing here, when we look at these bottom examples, we need to know the bases. We need to remember our curly Q technique to help us solve. And if we take a look at this one, fill it in. Just put a little 10 right there. Curly Q around. The base goes to here. So this is 10 cubed equals x over 2. Well, 10 cubed, you can type it into your calculator if you need to, but 10 cubed is 1,000. And then what we want to know is we want to know, well, what does x equal? So it's x divided by 2. We need to undo that division by multiplying over here by 2. And if we multiply the right side by 2, we need to multiply the left side by 2. And we get x equals 2,000. Use your algebra skills to help you solve. But as we take a look at our next one, what we need to know, remember, is that the base of a natural logarithm is e. Again, I recommend writing it in, and we can curly Q it around. So this becomes e to the first power equals negative 3 plus x. And we want to solve for x. We want to get x by itself. So we're going to add 3 to both sides. And we get e plus 3. And then we can go ahead and we can type that into our calculator to finish this problem. E, so we can do second and the division, e plus 3. Again, if you're having trouble with a calculator, make sure to ask your teacher for help on that. How we end up with 5.718. Last three. Same idea. We need to know, with regards to our natural logarithm here, which is what it is, that the base of a natural logarithm is e. Once we know that, we're going to curly Q. So that means to circle up and around. We get e squared equals 5 times x. And then it's 5 times x. We need to undo that multiplication by dividing by 5. And we can finish by typing that into our calculator. E, second, in the division bar, e squared divided by 5. And what we end up with, 1.4778. Because of that 8, I'm going to round that second 7 to an 8. We'll get 1.478.